Talk a little bit about one of the coordination processes that's called clash detection. And this is important on any kind of even fairly complex construction project where there's multiple disciplines. Now, here in this one, we're only going to deal with piping, but different systems of the piping. But you have to make sure that the pipes miss the HVAC ducts, miss the electrical lines, miss the drain lines, miss the gas lines, miss the rafters. Everything has to go in its own place. And sometimes that's hard to figure out how to do, especially when each group is working on their own thing and they don't have access to everybody's stuff. And so there's something called a coordination meeting where everybody does bring their work together, puts it all together, and then they can all work together to see what's hitting what and what's missing what. And that's called clash detection. And so, in general, let's see how it looks. A designer will model their assigned system and they'll export it to some sort of file type. In our case, we're going to model in Revit and export to dwfx. And then in some sort of a coordination file, we're going to use Navisworks. Okay, you're going to append or import everybody's stuff that they've submitted. So the electrical will send some in, and the gas line will send some in, and the vent and ducting will send somebody in, and the piping will send stuff in, and they'll all go into this master file. Okay, so one coordination file for each system. And then Navisworks will create a clash detection report, and somebody assigns responsibility for corrective actions, fixing the clashes so they don't hit each other. Okay, and that's usually a job site supervisor or foreman or something like that. Somebody does this responsibility. Then everybody goes back to their workstations or their offices or their companies and they redesign, they perform the corrective action that is going to be needed. And then, of course, you got to make sure that that worked. So at the next meeting, there will be a new clash detection report, and everybody will see that it was successful or not, right? Maybe, somebody moved something and it got rid of one clash and caused another. Okay, so these coordination meetings are really important. Nobody's wrong. Everybody's just trying to get to the point where the design will work. So let's see how that's going to work. So first, I'm going to open the file that we're going to use and go find it. It happens to be in the instructor drive. Okay, so go to my name and find clash detection at CAS, California Academy of Sciences. This was a file that I was allowed to keep, a set of files actually, that I was allowed to keep. I did the modeling in AutoCAD for this. It was quite a few years ago. And we've since translated them into Revit. But let's open up the base file that kind of contains a lot of the information that was put together from many of the drawings and my models. So this might take a little while. Each one is an older one, and they have to get updated. So you'll find that that's going to be a lot of your time. Once you update them, I would say you should save them because then they're in the most current format again. Okay? So you'll open these up and then save them into your drive. And let's take a look at it. This is the central utility plant. Okay, if you're familiar with the Academy of Sciences, the big albino alligator in the basement is right about there. And then there's a corridor that leads to a door right here, and all these pipes are right above your head. And you go through the door, and there's what's called the central utility plant. And this is a hallway right through here. And there's one room that has the chillers. Those make the water cold. And there's another room with the boilers. They make the water hot. And then over here is the cooling towers. Okay, where they actually cool the air conditioning for the building. Okay, and each one of these things has what's called a supply. It goes out and supplies the building, and a return that comes back and returns the water back to the chiller, as an example. And here there's boilers, heated hot water supply that goes out to the building, and then it comes back in and comes back into the boilers, heated hot water return. And then there's also, so this is cold water, CWR, that goes out to the building. Chill water goes to the big air conditioning evaporative cooling towers that they've got over here. So the chillers feed two systems: cold water supply and return, and chill water supply and return. And then there's one big thing over here there's the vent. So there's a number of venting operations. One comes off of the big engine that runs the power for these things, the generator. And then there's little pieces that come off of different pieces of equipment off of these things, off of the boilers, and then they vent to the roof. And this only shows the part that was mine. Okay, there was so much other stuff in here. There was electrical and natural gas, and there was liquid gas, and there were all sorts of other system lines. But these are the ones that I was responsible for, so I have the drawings, and I am allowed to use them for educational purposes. And some of you might have heard me talk about the job where the boilers didn't fit. There's all this work that shows that they can be rolled from this area through these doors and into here, and everything fit except the fact that these doors were too low because of the rollers, the 3-inch diameter rollers that these had to be put on. Then they didn't fit. Okay, so that's the base file for you to review if you'd like to see where these Revit files came from. And then the elevations for all of these come off of a set of basically drawings that sometimes the dimensions were on there and sometimes they weren't. We had to scale them and just get close. But we've got all these ones. CHWR, chill water return, chill water supply, cold water return, cold water supply, gas vent, heated hot water return, heated hot water supply. Those are each systems in the building. So we're going to pretend, even though I did all of those, we're going to pretend so that we can coordinate that each one of those is a different system being done by, as an example, a different designer. So they each have their own Revit file. Okay, now these are Revit files, and Navisworks can work with Revit, but usually people want to submit sort of a progress file. They don't want to submit their real deal file. There's too much stuff in it. So we want to take each one of these files and make something called a dwfx, a 3D DWF that can be used in Navisworks. And let me just give you an example. I'll open the California Academy of Science chill water return line. It's going to have to upgrade and update. And it always takes a minute or so. You can just sit patiently while that's happening. There it goes. And there it is. That's it. It's chill water return. It comes in from the building, goes through this pipe, and this pipe isn't showing it, but there's really a manifold, and a line comes from each of these to one of the chillers. Okay? So now that needs to be turned into a dwfx. And what I'm going to suggest is you make sure that the detail level is fine and that you're on hidden line. It's just the easiest way to see it. And when it goes across to Navisworks, it'll all look good. You can change it in Navisworks, but we want to do it right. So we're going to go to File, Export as a DWF. Click. And it should come up that says you're going to do the 3D plumbing view. And we can look at the properties, but that's all good, and the project information, and that's all good. And so we'll just go to Next. And where do we want to put it? I'm going to put it in my own W drive under Clash Detection. And you can see I've already got it in there. So I'm just going to call this one Demo. And there we go. I've got it. So that's your first step, is to take your Revit file and create dwfx files for your use in Navisworks. Now let me show you how that's going to work in Navisworks. So I've got Navisworks open, and this becomes what's called a project, and there's lots of things that you can do inside this project. But what we're going to do first is append adds geometry from some files. So I'm going to append, and I'm going to go find my files. And I'm going to look for DWFX. And look at all these different kinds of files. DWF, DWGs, FBXs, IPTs, OBJs, Adobes. You can actually bring Adobes in. Revit, you could bring the Revit right in. SketchUp. I mean, wow. This is a great program. Tons of stuff. And you can mix and match them. That's really cool. So you have to pick what kind, and we're going to use DWFX. And the first one I'll put in is, I'll put in the one I just made. And I'll double click on that. So there it is right there. And then I'll append another one. I'll do my chill water supply. That's it, right next to it. And by the way, this break right here, there are some pumps right below it. So these feeds the pumps, and then out of the pumps, it comes out at a higher pressure to go into the rest of the building. I can just do these as I go. Cold water return. Okay, so that's got this coming back, and cold water supply, that's the one that's going to the evaporators. Okay, I think I said that was chill water before, but that's cold water. Let me get my gas vents in. Hot water return coming back from the building. and hot water supply going out to the building. And same type of a thing, there are some pumps between this little set of pipes and this pipe. So there we go. Got the whole kind of thing sitting there. And you can tell, it's like, you can't tell what's hitting what here. But that's your next step. You create your clash detection file or your coordination file, and then you can save it. And I am going to save it as a Navisworks file set. So this will be my CAS, California Academy of Sciences, coordination file set. I can always get back to it. There's a couple of things you can do. First of all, you can look at your selection tree. And that tells you everything that's in it and gives you all sorts of, there's 4 pipe settings and 6 pipes, and you can see there's different ones, and there they are, and you can do all sorts of stuff to look at them and view them and see them and all that kind of stuff. It's just good to know that those are there so that it really keeps track of everything. Okay? But now the next thing that we really want to do is we want to go to the clash detective and find out what's hitting what, because I don't know about you, I even know where things are hitting and I don't automatically see them. I don't know if you can or not. I think there are 6 clashes in here. So let's take a look. We'll go to the clash detective. And the first thing to do is I have to add a test. So I'm going to call this test number 1. Okay, and sometimes they put dates on them and things like that. We'll call it test number 1. I need some rules. So a lot of times people will say, well, look, if there's a clash within this own file, they should have taken care of it already. So I'm going to ignore items in the same file. Okay, and sometimes if you have layer control, you can do that. But I'm just going to ignore items in the same file. That's a rule. Then I'm going to go to select. I'm going to select everything, each system, and see if it clashes with every system. Now, if I was in charge of just one of these and I knew ahead of time that everything was done, I could look at them one at a time. I could find out just where my chill water return might hit everything. But I'm going to do all pipes and see if they hit any other pipe. And then I'll look at my results. Oops, no, I won't. Then I'm going to run my test. I forgot to run my test. Bink. And I see that there are 6 clashes and they're all new. In other words, in this project, I have not seen that clash before. And that's really important to know, because sometimes you think you'll have fixed a clash and it'll create a new clash and it'll tell you. Okay, and so you can look at each one. Like I would have never seen that, and I wouldn't have seen that. Or that. Or maybe that. Or maybe that. Okay, and this says when we found it. So that's kind of cool stuff. That's really good stuff to know. Okay. And then if I click on one of these and I look at it in my selection tree, it'll tell me where that came from. Yeah, I want that to just go back. I don't remember how to make that go back right now. Oh, there we go. Okay. And so what I like to do is look at my report and then make the assignments. Because I want to know what's clashing with what. So let's look at the report. And I'm going to check item path also. Everything should be checked. I want to see everything. And I'm going to look at as HTML tabular and write my report. And I'll give it a new name. So that's kind of neato. If I go and look at it now, this is so cool. Gives me a picture, says it's Clash 1, and it tells me this is cold water return hitting hot water return. So usually the project will have a set of priorities. What takes precedence? What has to move and what gets to stay if there's a clash between two things. And I'll give that to you before we start. And that way you can pick who you're going to assign clash number 1 to. I'm just going to go cold water return. I'm just going to make it up for right now. Cold water return has priority. Usually it's the largest one. Physically, the largest pipe or vent gets priority. So, and I know the cold water return is bigger than the heated hot water return. So I'm going to say cold water return gets priority. So hot water return gets the assignment. So here we go, back to here, go to results, and I'm going to assign clash number 1 to heated hot water return and adjust elevation for min 0.1 clearance. And you'll just have to go in and look at these things and read them and figure out what you get. And that's 0.1 meter, by the way. So now there's a new comment that you can always look at and see. Okay, but now when we go to the report and rewrite the report, I'm going to put it right back over the top. I'm going to have to close that one or it won't work. Just to give you the idea of it. Now those comments are in there. So your first step is to, of the clash report, is to run the report, look over who's hitting who, and then go back to what I give you that says who has the highest priority and assign it to the other person. Okay, now you're going to do all the work. You're not going to trade around with class members, but you know, if you were cold water return and the fix was assigned to heated hot water return, you wouldn't have to fix your file at all. You'd come back the next week and go, I hope you did it right. Right? And see what happens. Okay, so you'll get something that looks like this for all of these. Now I need to show you how to print this thing. And, I won't be able to right now. Well, I can do that. So you set it up for Adobe, and then you're going to have to go to your preferences, and you're going to have to set it up as 11 by 17 tabloid. And that should do it, actually. And you have to set it up as landscape. Landscape tabloid, everything will fit. And this won't let me print because I'm not logged in right now. I don't think. Maybe it will. See if it let me print. No, I don't see it. But this is what it'll look like. And it's going to open up in Bluebeam because I don't have my other stuff open. My Adobe open. So that's what it looks like. Okay, and this is a really important document. This clash report. It's a very, very important document. Shows it, gives it a name, tells you whether it's new. Hopefully, next time you run this, you'll change the status to show that it's been corrected. Okay, tells you all about, who it's been assigned to, where it is, and some of the comments and the path for the different parts. Okay, so that's essentially the process. When you come back again to do this the second time, you'll run a new test. Okay, and when you look at your results, you'll be able to change status to resolved. Okay, if it's no longer there. And that's the goal. The goal is to have each one of these say resolved, 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 resolved by the time we're done. And it might take you a few iterations, time through it, to go through a few times. Okay, so there we go. That's the basics of Navisworks. For clash detection, Navisworks is used for a lot more. Timelines, quantification, you can render in here. There's all sorts of data tools available. You can show stuff and not show stuff. I mean, this is a very powerful program. Many people are moving away from Navisworks and towards Bluebeam Review. We used to use, before Navisworks came on the scene, DWF Viewer. So they're always making improvements to make it more and more clear what might be wrong in a design, where things could be a problem, and how to manage it so that it gets corrected in the most beneficial fashion. So there we go. That is the essence of our coordination and clash detection project.